Welcome to concavity. So just some quick definitions. F is said to be concave up on the interval I. If the derivative function f prime is increasing on I, and f is said to be said to be concave down on the interval I, if f prime is decreasing on I. So if we think of this in terms of f prime being the slope of the tangent line, we can kind of get a visual of what it might mean for a function to be concave up or concave down. So if we think of concave up, imagine the derivative. So imagine f prime going from -3 to -2 to -1 to 0 to 1 to 2 to 3. So we're looking at slope of tangent line. So we can kind of visualize what's going on. So we'll start off with a slope of -3 would look something like this. It has slope -3. So say here's our point, and the graph is going to start off looking like that. And then let's switch to a slope of -2. So it's still going down, but not quite as steep. And maybe now we're here. So we're kind of flattening out a little. And now, so that was m equals -2. And then, or f prime equals, right? And now let's go to -1. And again, that just means that we're flattening out a little more. Go to 0. And now the graph is completely flat. If we go to 1, it starts getting steeper in the opposite direction. And then a slope of 2 is going to be even steeper. And then slope 3 is even steeper. So essentially we have sort of a smile going on. So you can think of this as it looks like a scoop. Anywhere on that graph, it's kind of like we're scooping. So the graph is like a scoop. So we say it's concave up because it's like an upright cup or an upright scoop. And this is concave up. For concave down, let's go the other way. So let's say that f prime goes from +3 to 2 to 1 to 0 to -1 to -2 to -3. So we're starting off with that positive slope of 3. And then switching to a slope of 2. And then switching to a slope of 1. So here we're flattening out again, but sort of in a different direction, right? Then to 0. And to -1. And then to -2. And then -3. So this is not precise by any means, but you kind of get the idea. So in this case, anywhere along this path is like a cap. So we're at some way, we're kind of capping over something instead of scooping under. So in this case, again, the graph is like a cap. And so we call this concave down. It's like it's a cup that's facing downward or upside down. So this is just sort of the basic idea of concave up and concave down. In the next video, we will look at the relationship between concavity and the second derivative.